Friends, welcome back. More factoring. And just in case I didn't get you excited enough on difference of squares, we're going to talk a little bit more about difference of squares. This time we're going to talk about when we have something in front here. So this is why when you see a binomial, just two chunks, and it's a subtraction problem, I want you to zero in on it and be like, is it difference of squares? Because it probably could be. And we love throwing these on the SATs everywhere. This difference of squares are hidden in all sorts of things when we're factoring. So let's take a look at our first one here. Here we have so what I want is something squared minus, just a quick reminder, x squared minus y squared factors down to x plus y, x minus y. Now the plus or the minus can come in the front, doesn't matter, either front or back, doesn't matter. So this guy right here is really, 2x squared minus 7 squared, which means that this factors down to 2x plus 7, 2x minus 7, okay? Now, like I said, when you see a binomial like this and you're like, I want you to look at that and think, is it difference of squares? You look at this and you're like, well, those are not perfect squares, so it can't be a difference of squares. Remember, though, you can factor things out of here. So like in this case, if I factor out a 3, I'm left with 4x squared minus 9, and suddenly I have a difference of squares here. So again, this is a perfect square and a perfect square. So I have 3, and then I have 2x minus 3 and 2x plus 3, just like that, and I have factored that right down into it. Now, sometimes the difference of squares can be hidden. In a previous video, we talked about factoring by grouping. So let's take a look at that really quick. If I factor by grouping here, in this first one, I can take out an x squared, and that leaves me with x plus 5. Bring down my minus sign, and in this one, I can take out a 9, which leaves me with x minus 5, because I'm just bringing that down. Except, no, these two things do not match exactly. Notice this is subtraction, this is addition. That's because negative 9 times negative 5 is positive 45. I need a negative. When this happens, you usually messed up your sign. Okay, so looking at that, I now have, this guy is a factor, so I have x squared minus 9 times x plus 5, and you're like, bam, I factored this, I'm done. No, absolutely not, Captain. You are not done. I see x squared minus 9. That is a perfect square minus a perfect square. I told you, we hide these everywhere. This is going to be x plus 3, x minus 3, x plus 5. Okay, you're going to see these in your sleep. I swear, I worked with a student for like 3 years, and when he finally hit algebra 2, he was like, now I understand why you are drilling difference of squares all the time, because it comes up over and over again. Here's another good case where it is hidden. This is a nice one because we have x squared squared, because that's the same thing as x to the 4th, right? Minus 9 squared. All right, so what I have then is x squared minus 9, x squared plus 9. That will give me x to the 4th minus 81. And you're like, hey, I got that. I am done. No. I see a difference of squares here. Perfect square minus another perfect square. This is perfect square plus perfect square. That's not a difference of square. You can't factor that one. This one you can't. This one is x plus 3, x minus 3, and then we just bring this guy down here. So keep an eye out, especially on the SATs. They love to do that. Hopefully this helps, and we will see you next time.